in the air. What? So he was wrong, but I didn't tell him he was wrong. I was like, oh, nice answer. Yes, good idea. So it was awesome.
Yes, different ways to engage our students. Oh, that is such a fantastic share. Thank you for sharing out, Mickey. I'm glad that the slow reveal strategy is working. It is an incredible site. I got to meet Jenna this fall. She is prolific in what she puts out there, and she would love like thoughts and ideas and feedback and all sorts of things. So as you're going forward, Mickey, if you're like, I wish there was one on such and such, just email Jenna. She is totally open to different ideas and things like that. Anybody else have any updates or thoughts, questions about data or the series before we jump in more fully? Okay, as they come up, please share them out. Oh, we would love to hear. Excellent. Okay, let's see if this is going to work for you all. It should be slides. Do you see slides? Do you see something that says, ah, thank you. Yay, we will conquer technology today. Excellent. So we are talking about, this is sort of session 2 or topic 2 that we are going to be exploring, creating and iterating data visualizations. And this is one of my favorite things to talk about. So I'm so glad to be joining you all for the next little bit as we are working on this. Just as a reminder, if you would change your Zoom name, because we all come in from all different things. I think most of us are here. First names, if you'd like to share pronouns, you are welcome to share them in your name, and then subject area that you teach, just as we're getting to know each other and building across the cohort. And just a reminder, like we're asking that you come to 3 of the 4 topics. And so it does not mean we are always going to be seeing the same humans as we are in our Zoom sessions. And so this just helps us kind of orient to what we are, or sort of who we are outside of our Zoom box. And we are going to get opportunities to talk more to one another, but this helps us be able to use first names and talk to each other, things like that. The recording is only shared with folks in the cohort, and I really encourage you to keep your cameras on so that we can have those conversations. And then the major caveat that life is in session. And so please do what you need to do. 2 hours is a long amount of time. We will take a break in the middle like we did in November, but if you need to walk away because something else is happening, please turn your camera off, go on mute and like walk away and go do that thing, and please come back. Please know that we're here for a long time, but also we recognize that life is occurring in parallel as we are here together for these couple of hours when we're talking about this. Okay, other sort of encouragements, things like this, I'm just going to I'll share these, but then we'll keep moving in. So not all of us, or I shouldn't say that. It's been a little while since we've all been together. And so we are going to share a little bit about ourselves, where we're at today, this current day. And rather than sort of going round robin or popcorn and sharing out, or rather than me putting you into breakout rooms and you only getting to talk to 1 or 2 other cohort mates, we're going to co-construct some graphs together because it's the data visualization topic this month. So in our shared resource document, there is a link to the Google Slides that we will be doing. And let me just go right over there and share that so we can be walking through in real time what this looks like. So we are here on the top of page 17. Yep, the anonymous leopard has found it. So if you click on this link of the Google slide, it will take you to a visualization. Yep, sign me back in. To the Google slide that looks like this. Each slide in the slide deck is a different question. And on each slide, you'll see various icons that you can grab. So how many cups of your preferred morning drink did you have today? Well, I had 1 cup of coffee, so I'm gonna move that little like red coffee cup over. I'll jump over to like, okay, how many years have you been teaching? I have been teaching and working in education for 23 years. I'm going to put my smiley face there. And so each step, each slide, you're going to pull an icon to answer the question for how it relates to you. This page here, let me just bring this up. So on number 4, on slide 4, you need to not only pick a tile that goes to your location, but then you need to write in the actual number. So it was a high of 61 here where I live. So you're going to find the kind of bin to put it over, drop your tile there, and then use your phone or a thermometer, whatever you have, to type in the actual number, and then you can like stack them on top of each other if need be. Are we good? Thumbs up. Everybody's got following along. I see lots of folks in there. Excellent. I'm going to stop screen sharing so that we can each focus on this ourselves to answer my other questions. Okay, you can't get into the Google Slides. That is interesting. Let me see if I share the direct link in the Zoom chat, because it should be set up that anybody with the link can edit. Okay, Tracy, can you click on the link I just put in the Zoom chat? If others are having issues, please let me know. That worked for you. Okay, great. Thanks for letting me know, Tracy. Sometimes those hyperlinks get a little wonky with firewalls. Okay. Doing well. Take about another minute or so. Ooh, Carrie, we will circle back to that. That's a fantastic question. Okay. I think most of us are there. Once you've finished answering all 5 questions, you can go up and check out the other slides, see what folks have said, see where you line up. Here, I will share screen as well. Do we need to do attendance? Don't worry about that. I'm capturing it, but thank you, Kim. Great question. Okay, so we are, ooh, there are a lot of water drinkers in our group. Fantastic. Also, good number of coffee drinkers. Excellent. You know, that often is the case. But a bunch of kudos to those drinking 5+ cups of water today. I am constantly attempting to stay fully hydrated, and so I'm going to draw inspiration from you all. We have an incredible wealth of time and experience and expertise and experiences that we have had in the classroom here for those joining our cohort live today, from everything from, it seems like, about 5 years to 28 years. So first off, the human who has been with us for 5 years, thank you for rolling with us, which might possibly be some of the 5 wonkiest years we have had in the K-12 system, at least in my lifetime. So it should hopefully just keep getting easier for you as you go through your tenure here in teaching. For the human on the call who's been here for 28 years, thank you so much for your service and all that you do for their students and for everybody else in your district. That is incredible. I encourage you all to really leverage this cohort. There is such incredible depth and breadth of experiences. Okay, this is always the big one. It's like, okay, so as we stay in education, do we therefore need more morning drinks to make it through? And we've got a little bit of, a relationship going on here, but we also have some other clumps going on. So I would not say that this is a like lockstep positive relationship of the longer we are in the field, the more morning drinks we need to make it by. So you who've been only here with 5 years, don't worry. You will not have to start drinking lots, but you already drink lots of water. So you can just maintain that and inspire all of us as we go through. Okay, let's see about our temperatures. Whoo, Nelly, we got a lot of you that are in the like 46 to 50-degree range. And we sort of have our two components on the side, and then most of us are clumped up here. A fun way to see a histogram of our times. And we've got a great range with a lot of us feeling like on the confident side of teaching data skills, and some of us still in the like are in the like or ooh, I'm not really sure about this data skills thing. And I would say welcome all of you in all of your spaces. We are here to support you. See that your colleagues have more confidence or less confidence, and really lean on each other and support each other as we go through different things. Other insights, thoughts, noticings people have as they're looking through these different graph types that we have as we're getting to know each other, landing here today together?
I think the drinks and years of experience is interesting. I also wonder if you took out water, would it change a lot?
Oh, I like it. So like on that first page, on the first question where I gave the options of coffee, tea, soda, water, other, Mickey, what I'm hearing you say is like, well, what if we took out water? Or what if we, forced it down into two options or things? How would that then change what we would see on the years in education versus number of morning drinks? Ooh, I like it. I like that sort of building off of question, off of the visualization we have. Other noticings or wonderings folks have looking at our co-constructed graphs as a group? Besides Carrie's, which is in the chat, and we will be circling back to that, Carrie, I promise. Okay, so this is a great way to have your students look at data. This is in fact one of the strategies that we are going to be talking about today is co-constructing visualizations together as an opportunity for students to practice and work on their data visualization skills and their understanding of data visualization. This was inspired by the project Dear Data. Are any of you familiar with the project? Sorry, I'm trying to find you all. Have any of you seen Dear Data? No? No? Okay, just a second. Let me stop sharing for a second. Let me try this again. You all are so patient. Thank you. Take two. Now, can you see something that says Dear Data and observe, collect, draw? Excellent. Okay, so Dear Data was a fantastic project, and it resulted in things like this. It was from two data visualizers, Georgia and Stephanie, and this happened about, gosh, at this point, maybe 10 or 12 years ago. And one of them lived in London and one of them lived in New York City, and they decided to just do kind of a fun project of like, let's collect data about our lives and then send each other our visualizations of it. So one thing I love is that it helps us, sort of them thinking of like, oh, what's data I could collect about my life? Two, to sort of get at the like data are all around us and we can constantly be we can be thinking about information and sort of thinking, oh, how could I look at data about this component of my life? Two, I also love this project for our students because this is not straight lines. This is not like Google Sheets, it looks perfect with the perfect bars, but it was all hand-drawn data visualizations. They put all of their postcards into a book. Now, I am not saying that your students would necessarily create something like this complicated. The front of the postcard was the visualization, and the back of the postcard was the legend. So this is like quite a legend to read the visualizations. But what I do think is really fun is this, their second book, Observe, Collect, Draw, which they came out with a couple years afterwards, where they have all sorts of suggestions that you can ask your students. And so I am not trying to promote, like, force you to buy a book, but just saying, like, there are all sorts of ideas. So here's an example of like the books on your shelf, or how many pages that have you read, or different things like that. Different questions that you can ask your students to get them sharing about themselves and practicing visualizations. Because there's this really funny thing that happens when we're asking our students to talk about themselves. They sort of forget that they're doing the skill practice of it, and they get into the sharing about themselves. For our younger students, this is amazing in helping them understand the representational nature of data. As in, I had 1 cup of coffee and I can see my coffee cup there on the slide, and I can look around and be like, oh, there are other humans on this call, and we all had different numbers of different drinks throughout the day, and their cups represent them. That representational nature of our data visualizations is a really big piece for our younger students to see. And so this helps with that. But back to our students sort of kind of forget the fact that they're like practicing how to construct a visualization, because for them often it's just like, oh, I'm answering the question about myself. And so how can we get our students answering those questions? Well, in a variety of different ways. You can totally take this Google sheet, make a copy of it, and adapt it out, change the questions. I was trying to build this so we had a range of different visualization types. So we've got a line plot, a scatter plot, a histogram. We've got a Likert scale in there. We've got what you could sort of smush all of those cups together to be a bar chart across different categories. So I was trying to create it out so we had a couple different types of visualizations. So you can totally do that. I have to say, this used to be in Jamboards, and then they got rid of Jamboards. So now I've adapted it to be in Google Slides. So please, like, totally feel free to copy this and riff on it. Or you can do it in some other ways. So you can physically have your students do it with stickers on a flip chart, or do it with post-it notes. So this post-it note one is a great way, especially for all of you science teachers, if you're having your students do an in-class lab or investigation, and they're each recording values, have them put it on a post-it note and then sort of display the whole class data. So you can do it with physically adding things to something. You can go one step further into the physicality of using actual manipulatives to build out. And this is like, Duplos make us think of kindergarten, but can be really helpful for our middle school and early high school students because it's very different than how they usually interface with data and visualizations. And so certainly not every time, but it can sort of shake things up a little bit as a like, as they're walking in of a bell ringer, or sort of last thing on Friday before they're walking out type of thing, sort of shake it up. There's also a great opportunity to have them physically move their bodies in space. Again, all ages of students can benefit from this. It can sort of shake up a longer period. It can sort of help with that, like, what are we doing? What are we actually thinking about with these data values? Or you can go full on to your data and have your students think about their own way to visualize the data. So there are a variety of different ways you can have your students sort of working on, thinking about, constructing the visualizations. But the strategy here is get them talking about themselves as a way to kind of backdoor practice some visualizations and exposure. So, Carrie, did that question, did that response kind of answer your question or comment of kind of how we can incorporate this or something like this in your classroom?
Yes.
Awesome. Okay. So now that that answer is yes, because I was going to try to make sure that we circle back to that. What are some thoughts, questions that folks have as you're kind of hearing me present this as a broader strategy, not just something that we're doing as a kind of an icebreaker, a slide in, settle into our session today? Anything coming up for folks? I see some yeses in the chat. I'm not sure when those came through, but hopefully they were positive affirmations of something. Fantastic. So this is one strategy that we can use as we're thinking about creating different opportunities for our students to create visualizations, is kind of switch it up on them a little bit, give them an opportunity to practice visualizations in a way that they don't think they're practicing visualizations, and sort of creating that opportunity. As a reminder, we are a cohort of many different disciplines and many different grade levels that we are working with. And that was on purpose, because there are a lot of things that show up in science, which is in green, social studies in red, and math in blue, that have a lot of overlap as we are working with data and making sense of data and the critical thinking that we need to do with data across our different disciplines. And so what we're trying to create with this cohort is a way that we can sort of build a common language and use a common framework on how do we help our students make sense of data and work with data. Visualizing data being a big component of that. Now, there are many other components, like last month or like this fall, we were talking about the interpreting data to learn something piece. Usually we are looking at a visualization. So today we're talking about visualizing data piece of it. So there's lots of different components. We can't talk about them all at once, which is why we sort of pulled them apart, and we're doing 4 of the topics this year. But just to say, teaching someone how to make sense of data and how to work with data is a big thing. And it is a K-12 progression that we are working on. And each of us hold different pieces. It's not on any one of us to do everything, but it's us on thinking of, okay, what's the piece I can do? How can I help shift the needle for my students this year? And graphs, I put graphs in quotes because we also have charts and plots and maps and all those things. This was to make my English language arts teacher, back in the day, really proud that I actually did remember something. So graphs are to data what goals are to soccer. We can absolutely play soccer without any goals. And when we get to the World Cup and all of the, like super high level, it is really interesting to watch soccer when it is a 0-0. But otherwise, it's not actually that interesting. Like, the whole point of soccer is to score goals. So we can absolutely work with data without visualizing it, without making visualizations, but it's not as interesting. And also, it's a bit harder for us to see those insights, especially those of us that are visually able. And that is because of this. So I'm going to read this. Some of you might have already been starting to read this. Those of us who are visually able are remarkably visual creatures. So exit this room, hypothetical room because we're all in different rooms, but exit this room, turn right, walk 2 feet to the end of the hallway where you'll face the door to the living room, turn right and walk another 10 feet to the front door, open the door. I've already forgotten which way I was supposed to turn the first time. But if I show you something like this, you can pick up the information from this visual, from this diagram, orders of magnitude faster than you can reading the text or even hearing me say the text. And so those of us that have our visual acuity, we process the information much more quickly. This is why data visualizations hold such a big space, because we can see things differently when we are looking at cups in terms of the morning drinks we have than if we were going to look at a data table and see coffee 1, coffee 1, coffee 1, coffee 2, coffee 2, other 2, other 2, water 1, coffee 3. Like, if we were to just look down a data table, things jump out at our eyes differently than if we're looking at it. Sorry, I still have the coffee table, the cups for morning drinks still pulled up on my other screen. So we see things differently there than when we are just looking at numbers or words in a data table. And that's to our advantage to help us learn something from the data, what we were talking about earlier this fall, and those components. This is why it now shows up in our math standards, our science standards, and our social studies standards, that our students should be looking at data visualizations and making sense of them, sort of making meaning from them as they're going forward. Yay for those of us that are visually able. There are all sorts of cool things that are going on about data sonification for helping those that are not visually able, how to make sense of data. Also, I always for physical, the physicality of like making, especially with 3D printers, being able to make data representations three-dimensionally as another way for those without visual abilities to see the data visualizations. Super cool. But this sort of begs the question of if visualizations really help us see things, then which visualization type should we use? And we're going to do like a little bit of a poll here across our cohort to figure out what are we using now and how are our students deciding? Specifically, what kinds of graphs, charts, plots, maps do your students make right now? So that's number one. And number two is how do they know which graph to make? When you're having them make a graph, how do they know which graph type to make? Okay. What I'm going to do, what I'm going to ask is that we do this as a waterfall. So I'm going to ask that we all jump into the Zoom chat. We type out our responses. If you could also put in what grade level you teach, that would be super helpful of these responses. But we're all going to put them in. And then when I say one, I'm going to count, I'm going to sort of time us and count down. When I say one, we're going to do this waterfall in and see what kind of graph types our students are making across our different subject areas and grade levels. And how do they know which graph type to make? Does that make sense? Thumbs up. Yeah. What I'm asking you to do? Okay, awesome. Fantastic. Okay. So everybody think about those two questions, type them into. Okay, 10 more seconds. Are we good? Number one, what kind of graph types do they make? Number two, how do they know which ones to make? Okay, let's see them. Kim jumped the gun. She started us off. Excellent. Okay, we got line graphs and scatter plots, pie charts and line graphs. Coordinate grid. So scatter plots are line graphs, bar charts, line graphs, bar charts. Ooh, we have a lot of things coming through. Histograms, box plots. Thank you, sixth grade math. We dearly love you. Bar charts. Excellent. So we have a lot of overlap. Even though we teach a range of students different subject areas, there were a lot of lines, lines, scatter plots and bar charts that were showing up as I was reading through. Some of them had, whichever one, I so appreciate this, Teresa, whichever one have the most colors visually appealing. Yes, this is often the way our students pick their visualization type. Or, well, this is what Google Sheets chart editor selected for me. Or another one we hear a lot when we interview students is, I thought this looked the most complicated, so it's what my teacher would want, right? So these are different ways to select what graph types our students can do. What about for some of the question? I'm trying to read through the chat. It's hard. So they came in so fast and furious. Carrie's saying they know which ones to use because I tell them. Okay, Carrie, thanks for sharing. That was totally the space that I sat in. If they're comparing categories, this tells them what graph type to use. Andrea was sharing. Patricia's saying, make these because I say so. So it sounds like this one's coming up a lot. Like we are telling them which graph types to make. Excellent. We discussed, Jameson saying we discussed the pros and cons of each of those. Awesome. Other aspects that are factoring into how your students are identifying which type of graph they should make when they're making their graphs that folks want to share out. Besides, we tell them, we discuss pros and cons, or it's sort of determined by the data type that we have was the other one I saw. Mickey.
For a science class, they usually just do whichever one they're most comfortable with. And that's not always the right choice to make, but They seem most comfortable with bar or line graphs, so that's what they'll choose, but that's, yeah. So I end up walking them through. I explain ahead of time, like when line is appropriate, when graph is appropriate, but they're not always listening. I think they think they're in a science class, so math doesn't matter, but of course we know it does.
We know it does. It's so important. Thank you for both of you. Like both of these disciplines that support each other and complement each other. Yeah, like what our students are familiar with is a really big component. And while it can be really frustrating, for example, Mickey, you're saying like they use a bar chart when they should not. On the other hand, it does mean they've made a mental model. They have connected data and bar charts together, and they've thought about that, which is great. They have been seeing bar charts since kindergarten. So a lot of that, by the time they come to see you, right, Mickey, you're middle school science, is that right? Am I remembering that correctly? By the time they come see you, they've had 5, 6 years of seeing data and bar charts, data and bar charts, data and bar charts. Now, I'm not saying bar charts are the only ones in elementary school, but it's a really common one that they have seen. So in some ways, we should celebrate. They're actually remembering something that we are showing them, and they've created those mental models. The tricky thing is how do we get them to expand that mental model to be a, but how does it depend on what data I have, which you guys were talking about a little bit, and also what are we trying to do with the data? Because as we were going through and pulling together that list of visualization types, there were 3 that showed up a ton, right? Bar charts, line charts, and scatter plots. But then there were maybe sort of 5 or 6 others that were showing it. This was my guess of what you all would say: bar charts, scatter plots, line graphs. And I thought maybe we would get some line plots showing up. That's a common one in elementary school. It really should have more of a space in middle school, but we can talk about that more. There are 14 visualization types that we want our students to be comfortable and cognizant with by the time they graduate 12th grade. Where did these come about? They are explicitly stated in our math, science, or social studies standards, like box plots are explicitly called out in our math standards, or they show up on our state assessment tests as visualizations our students should be able to read and make a claim from, or they show up a ton in social media feeds, in news feeds, in electricity bills, things like that. AKA, we are graduating our 12th graders out into society. What are the visualization types that they are going to see? So it kind of begs this question, Mickey, you're bringing up, like, they love the bar chart or the line chart. They just keep going back to those that they know. So how do we help expand out their understanding? Part of it has to do with what data we have. I forget who mentioned that in the chat, but it's a great thing to comment on, of like, if you have categories, you are looking, you can visualize your data differently than if you have a numerical data, a continuous number line. The other really key piece for our students is that what we're asking of the data, why we're trying to use those data. This is easier in our science class because oftentimes we have a like, we're working towards a content area, or we're trying to figure out something, but it is just as relevant in our math classrooms when we're teaching about how to make the box plot. What are we even trying to determine from that box plot when we're using data in it? So helping our students think about the type of question that is being asked can be really helpful. So we have 3 primary types of questions that show up in K to 12. Comparison questions, where we're comparing 2 or more groups. Are they the same? Are they different? Which is more? Which has less? Are they correlated? What's the kind of relationship? How do we model fit that relationship? Those are all comparison questions. We really like comparison questions as humans. But there are also a subset of questions that are distribution questions, where we're looking at the variability of a group. How tall are 5th graders? How long do hurricanes last? Those types of questions are distributions. We're sort of looking at how long have we been working in education? That's a distribution question. We're looking at sort of what's the range and the shape of how long each of us have been working in education to get a sense of this group of us. And then we have composition questions where we're looking at how the total is proportioned into different subgroups. So like, how many of us are born in December? Those types of questions. So we've got these 3 types of questions. I don't know about your lovely students, My seventh graders absolutely could not tell me what type of question they were asking. My undergrads cannot tell me what type of question they are asking. So we have attached sort of common words we use when we're describing the data, when we're making noticings about the data, when we're making claims about the data, when we're talking about the different quartiles and different things like that. So we've added these describing words to kind of go along with the type of question for this resource. And this is important because if we're asking a comparison type question, that gives us a subset of those 14 visualizations that we'll pull from. And that's similarly, if we're asking a distribution question, that gives us a subset that we're going to work with. There are more than 3, there are 14. But then we also have to, so then the next step down is, okay, are we comparing among items? Items trips people up a lot. Think of among categories. Are we comparing coffee versus tea versus soda? So that's our among items. Or are we comparing between variables, years in education versus number of morning drinks? Are we looking at a distribution within a variable? How many years we've been working in education, or between variables? Are we looking at a composition at like static in time, at like one point in time? Or are we looking at something, or space, time or space? Or are we looking at something that's like the composition and how it's changing over time or changing over space? We just lived through the election, and so we saw a lot of static and space type of questions. We were like, from the election, what were the outputs? We looked at a lot of composition visualization. There were a lot of composition visualizations, maybe that were showing up in your feed, or were certainly all over the news as we were making sense of the most recent election. Happens every year as we go through. So those are kind of different examples of like what these could be. So now the trick is, how do we take those 14 visualization types and connect them up into these different types of questions? How do we know which of those subsets of visualization types or graph types could go with each of these questions? So we are going to do a little activity where we're going to explore this. Now, before I get much further, I want to say, if you saw a visualization type there in the 14 and you're like, Kristen, I have no idea what that is. So we're going to say, don't worry, happy Tuesday. I'm not testing your knowledge of the graph types. I'm just asking you to join a breakout room and have a conversation with your colleagues about the graph types you do know, about the ones that you are really familiar with. So if any of you are like me and you'd be like, this is making me nervous, don't worry, you just get to ignore the ones you don't know. This is not the point to be like, let's test your knowledge on all these visualization types. Most of us don't use them because, again, we do data across math, social studies, and science. So it is not on any one of us to do all 14 of these. And we will circle back about like, and when should our students be learning these different visualization types? But we're going to do the activity first. So how to get to the activity? We are in our resource document here on page 17. Based on your breakout room that you go into, you're going to click on a different one of these links in the resource document, and it will open up to look something like this. It will remind you what we're trying to get at, which is like, how do we help our students figure out which graph type to actually use without it always falling on us to be the ones constantly telling them, which, like, no shade on that. Time is of the essence. Time is a limited resource. Sometimes we just need to tell them. But if we're always telling them, we're not actually kind of helping them learn the skill of graph choice. So on slide 2, I kept in sort of the description of the types of questions and the describing words, because I find those sometimes can be helpful. Slide 3 is the one that you want to look at and go for. And so let me scroll out a little bit. So what you will have is you will have these different visualization types. And what you can do is you can grab the square and bring them over. This is Google Sheets. They're all in a group. If you grab one part, it'll sort of spread out. Thank you for rolling with the fact that I'm like making it work as we're all remote and all those things. So in conversation with each other, I want you to find the visualization types that you're familiar with and think about, scatter plot, like, when do we use that? is that, you know, does this make sense in different, I'm just randomly putting these on the page, by the way. So I will move them for breakout one. So you access your Google Sheet, Google Slides document based on your breakout room, and then you go to slide 3 in your document, and you should be able to move these around. I really think I set all of the setups correctly. Let me assign breakout rooms. Are there any questions before I open the breakout room? Okay, we're gonna do this activity and then we will do like a quick debrief of it and take our break. But I wanna sort of have us have the opportunity to do this. Okie dokie, excellent. Open the rooms, ping me, let me know if you can't actually get into the Google Slide document for your breakout room. Otherwise, have fun. We'll come back in about 9 minutes or so. Okay. As everyone is coming back in and joining us. So before we go on break, I've got a question for you. We will continue talking about this activity when we come back from break, but I want to make sure we have break. We've been going for about an hour. But before we do, I want to sort of pull you out of the details of like, what are these different graph types and which questions do they go to? And how do we think about examples that we maybe have seen before to try to make sense of this activity that Kristen's asking us to do? And I want you to kind of step up to the level of just sort of reflecting back on that experience. On what did it feel like? So feeling things can be like, I am so excited. I know so many more graph types than I thought I did. Or it can be, Kristen, what are you doing to me? It is Tuesday evening after a long weekend. I thought I really knew my graph types, and now you're really frustrating me. These are like feeling statements about how we could have felt, about how that went, of thinking about graph types that we are familiar with, that we have used before, in this context of, but which types of questions would I use that graph type to help me explore or to answer? You can share your feeling comments in the chat. You can unmute and share them out. But I'm just encouraging us to sort of pause and reflect on what was it like to think about graph types from this angle, this perspective. Amazing. Yeah.
Well, I learned a new word, which is choropleth.
Nice.
Didn't know that word before.
Awesome. Awesome.
So Google told me it was a temperature spread graph. So then it was like, okay, I have seen one. I just didn't know that's what it was called.
So. That is really interesting how Google defined it. Excellent.
Well, Google didn't use those words, but the temperature graphs of the country, like, it's shades of 90s over here. And so that was interesting. I think for myself, the when we were doing the sorting, it was easy to get lost in the nitty gritty and wonder which one goes, is it distribution or is it composition? And I think for me, the hardest part was not having labeled axes. So trying to think of things that the graphs, so not having a context for the particular graphs made it then difficult to think about, is it composition or is it distribution or is it whatever the other one was?
Distribution,
comparison.
Yeah. We as humans and us as adults really like specifics. So this is something that we hear often, probably every time we run this activity of like, but I want things on the axes. And I will tell you after the break why there are not things on the axes. But thank you for sharing, Daisy. That was awesome. We're also getting in the chat uncomfortable. I imagine the way I'm feeling is the same way that our students often feel. Stretched and challenged. Glad we're learning when to use the graphs, like learning some new graph types or thinking about it from this angle, from this perspective. Anybody else want to unmute and share some of the, yeah, Patricia.
It instantly just brought me back to college, but I also just was using like context clues. And I just instantly found like some patterns, like, oh, like all these plot graphs are kind of going together. But then like, and one of them was like peaks and valleys. And like, okay, that one's going to go here because it looks like peaks and valleys. And so I was just kind of really looking at the visuals and kind of like, what does it kind of look like? And then just noticing that we just kept putting the graphs that kind of look similar together in the groups. And so I was just doing that.
I love it. So, Patricia, what I hear you saying is like you were looking for context of what was physically on the page. And Maisie, you were thinking about context of like prior experiences or sort of thinking about context in which you might have seen one of those particular visualizations previously, sort of pulling on that kind of prior knowledge forward. Ooh, so fantastic. Laura, do you want to add something new to the conversation or build off of? No? Okay, awesome. Okay, so we will come back to this, but we've been going for an hour and it's important that we like take a break and walk away from the screen and like take some minutes off. So we are going to come back. We're going to be going again by 5:40. So come back like a little before 5:40 so that we can kind of situate in and get going, but please get water, use the bathroom, get some food. It's dinner time for most of us. Do what you need to do and we will be back at it. We'll sort of circle back and take the next steps on this. Awesome. Thanks, everyone. Back from break. Hopefully folks were able to like walk away from the screen for a little bit or at least shut it off and sort of look at something else. Excellent. So let's think about, so we had this, many of us were feeling a little stretched, a little uncomfortable. This is a new way to think about visualization types. I will share, I was the exact same way. The first time anybody introduced me to this concept of graph choice and how what graph type we use relates to what we're asking from the data, I was sort of like what? Like, I just learned how to make the bar chart, like not when to use the bar chart or why to use the bar chart. And I should also say, so there are 14 visualization types we're trying to have our students do. This is one of many books that is just like hundreds of different visualization types that are out there. And it is not realistic for us to try to hold all of those to teach our students because there are forever new visualization types coming online. But if we can get our students to learn these 14 across our subject areas, K to 12, then we are setting them up for a lot of success on being able to make sense of new visualization types that, again, might come across their social media feed or their utility bill, or they get asked to use it in work, different things like that. So it feels a little comfortable. Thanks for rolling with that discomfort. Thanks for rolling into that, like we're leaning into our learning edge a little bit. There's a resource coming your way that is all about what each of these 14 visualization types actually are and how to make them in Google Sheets and CodeApp and things like that. It's coming your way. So if you want to dive in deeper to that, we can totally do that. But what I do want to share is what could this have looked like as you guys were putting together your key, as you were constructing your key for what visualization types go with which kinds of questions? And more important than does this match actually what you all created on your Google slide is the fact that we can now take this and match it up with the describing words that we use and the types of questions that we use. And we can think about which of these visualization types our students are learning when, because you might be noticing this says high school up top on this slide. So what we just did is like all 14 that they should know by the time they graduate high school, that they should be familiar with. This can be a resource to help your students so that they're not always looking to you or they're not fully dependent on Google Sheets chart editor and what it spits out, things like that. And so you can run this activity actually exactly the way we did with your students. You can print out this copy of the PDF for your students if you want them to put it in their digital notebooks or if you want to print it out and put it on the wall. There are various different ways that folks that we work with can have been using this and have been sort of leveraging it for their students. So Mickey, absolutely yes, we're like right on the same page. You can print it and post it in your classroom, 100% something to look to. So this is what it looks like for high school students. This is what it looks like for middle school students. There are fewer visualization types that we want our middle schoolers to be working with. And those of you that are like in middle school, in the 6th grade area, you're like, man, they come in without so many. I just want to like hold space strongly for these are the kinds of visualizations that they are working with in elementary school. And this grading, or sort of this tiering of our visualizations of what we use at our different age levels, is based on developmentally how our students are thinking. So are there some students in elementary school that can look at scatter plots or line graphs? Absolutely. But you need to conceptually understand multiple variables in order to understand the coordinate plane. You also need to know what the coordinate plane is before you can make sense of a line graph. And so, not saying that these can't be taught earlier, but just saying developmentally, they need to have those components to them. And so this one shows up a lot in elementary science classroom. So I'm just saying, like, this one shows up sometimes in our 5th grade, sometimes in our 6th grade math classroom. So like, this isn't to like lockstep these lines or like things we can ever cross, but it is to indicate that the answer for any of you middle school teachers that are like, oh, I just wish they knew more coming in, it's they're doing a lot. And developmentally, they are very concrete thinkers. Our littles are very concrete thinkers. And we want them to be thinking really concretely and getting that visual representation down and understanding of that, oh, this is a case. Like, I drank a cup of coffee, and so I can see myself in that graph. We measured how big this pumpkin was. I can now see that in the graph. Sort of that connection is really key for them. We need to start thinking more abstractly to be able to look at the whole group, to be able to get a sense of like, okay, so what does a histogram offer us? Well, it offers us a sense of like the overall distribution and the shape and like what are all of our values of the whole group, not of this was my response because I drank coffee today. And so that's a different cognitive level of thinking that goes into it. And then our high school students can go even deeper. And so they can be thinking like with a bubble chart, well, I can look at, not only can I look at 2 numerical variables, but I could look at a third, and that's what adjusts the bubble size. And so this gradation of the visualization types is linked to sort of where developmentally our students are thinking, irrespective of data, but how that overlaps and plays with the visualization components. So as I said, you can use this, you can print those like grade levels, whatever is appropriate for your grade band, put it on the wall. You know your students. So if you want to do the high school one and you're teaching middle school, have at it, you know your students. But this is, we've developed this out to be like, okay, so what are the ones that I should focus on? Because right, I said, each of you individually do not need to cover all 14. But these are the ones that show up in our elementary years. These are the ones that show up in our middle school years. And there is some great difference for those of you that are teaching middle school, where there's a lot that comes online in middle school. Wait, let me go back to it for a second. There is a variety of different ones that come in. And so if this is elementary, this is middle. So there are a lot of new ones. So hence why I was so excited when you shared histograms and box blocks. So I was like, yes, not only do they show up in the standards, but we should be using these more often, different things like that. But they're brand new. The chances are very high that they have not seen them before they come into your middle school class, things like that. Whew, that was a lot of me talking. What are some thoughts, questions that you have about how these 14 visualization types either connect up to those 3 questions or get kind of scaffolded or sort of progressed through our elementary through high school classrooms with our students?
So I'm wondering about histograms and if they call them something different in elementary school, because I cover them in 8th grade and they look at me like they've never heard that word before.
Jameson, do you want to jump in and talk about histograms? Because you brought it up earlier as something they're doing in 6th grade math, in your 6th grade math.
Yeah, that's part of our, well, we're not at the elementary level, but they've never seen them before, usually before I get to them. So that's part of our 6th grade standards that we have. We do histogram, dot plots, although they're called line plots in yours, box and whisker, stem and leaf plot is a really random one that we do that I always like to turn on its side and show the distribution that it creates with it. Yeah. What else
Yeah.
about that? I mean, yeah, normally
So
they're used to the bar. So we always end up having a discussion about the difference between a bar graph and a histogram. And when we'd want to use the histograms, making sure that we're grouping data, like really big sets of data that we can cluster into groups. And they have these ranges or intervals that they cover that are all equal length, equal size intervals, the class widths, and
yeah, so one thing, Mickey, would be to talk to the person in your building or in your school district who's teaching sixth grade math, because it is explicitly called out in sixth grade math that they should be learning histograms. Now, that does not mean that they remember them by eighth grade, but I would pretty much guarantee that they have seen them in your sixth grade math class.
And on
In
your very early showed the Duplos
Mhm.
with that's a histogram, and that would have been like first or oh no, that's not them adding to. Oh, okay, sorry.
That's a no. It's a really great question. So the Duplos are a bar chart. So
Oh,
wait, actually, I have some slides to share this because I thought this question might come up of the like histogram versus box plot, because it often does. So let me jump to this and then we'll come to other questions. So it's in here. Bar chart versus histogram. Okay. So in a bar chart, we're looking at categories. So on that Duplo example, Mickey, it was sunny days, rainy days, cloudy days. So those are different categories. Here, I've taken this, what we call a line plot in elementary math, and then somewhere between fifth and sixth grade, we shift and call it a dot plot because we learn line graphs, and that gets really confusing for students. So it is a line plot on what we looked at, but really usually we're like a line dot plot because we make this transition. So this is a frequency, but here we have, it's like, if you got in the 60th percentile, that's a category as this is being shown right here. And so we could do like the category, and then our bar chart is like, well, how many fell into those different categories? So there's spacing between the bars because they're distinct categories. And the y-axis on our bar charts, it's the actual value, it's the count, or it can be the mean, especially once we get into middle school or high school. What is tricky is our students make bar charts of counts. And the reason why that's tricky is because in a histogram, it is a frequency, which is also a count. But as Jameson was saying, that frequency, it's binned. So here I've changed this, rather than it's just a 60, 70, 80 as a category. I'm like, well, what if you get between 60 and 80% on this spelling test? Then we have, okay, 3 people got between 60 and 80, and 8 people got between 80 and 100, and 4 people got 100 or above. Now, this is a really annoying thing of Google Sheets. They put in gaps here between the bars on a histogram, which technically there should not be because it's a full continuous number line. So this is the biggest difference between our bar charts and our histograms, is that our bar chart is of categories and a histogram is of a continuous number that we've binned into groups. I don't know if that helped, but hopefully sort of seeing the same data set arranged in different ways could help. It gets tricky when our categories are numbers. It also is tricky because in elementary school, we make bar charts of counts, so they sometimes can get a little confused of like, but I'm doing a count, I'm doing a frequency. But the biggest thing is, do we have categories, or is it a number scale, a numerical variable that we've put into these bins of number brackets? Did that help, Mickey?
I'm not sure. Can you go to the chart where you showed us what they learn in elementary school?
Yeah. Just a second. It's just taking a little. Oh, here's elementary school.
Oh, okay. I thought I saw somewhere else there were histograms at the elementary level. Maybe on that one.
So this is the histogram and this is the bar
Okay.
chart. Yeah, these should be closer
Oh,
together. Sorry, that's a
what's-
little confusing.
What's the one to the left with the colorful dots next to the bar chart?
It's a pictograph. So
Okay.
this is a pictograph. It's like our line or dot plots, but they use icons to indicate. So rather than X's or dots, it's a little like I had one in there, but I took it out where it's like hockey sticks or pumpkins or cars or trucks. Like they're using a visual icon to represent the data that's showing up in the visualization. Does that help?
Yeah, I'm trying to
Okay.
answer my own question in my head. So good. Thank you.
Okay. Awesome. Are there other questions or thoughts about thinking about these 14, either across the 3 question types or sort of how we progress them out across our grade levels? We've got kinder through high school here in the cohort. So, oh, Patricia, are you talking to us? Because if so, you're on mute. Okay, I think not. Okay. So, this is intended as a resource. So Mickey, you can totally print it out. As I said, you have, I put in a link in the resource document where you can access like all of the materials. When it's all set up, ready to go, you can just print it out and cut it out or copy the Google slide and have your students work digitally if you'd like to do it for elementary, middle, or high school. So different opportunities. Folks have done it in a variety of different ways. I'm going to come back to Maisie. I think you were the one that was saying you were like trying to think about what was on the axes, right? When you were going through it. Okay. So what we have found when we had things on axes, when we took actual graphs from the real world and put them into this activity, what we found is that people got really caught up on the data of the graph and missed the graph type of it. So what I will say is that a good number of teachers, especially in actually all grade levels, have found that sometimes it can be really helpful to review a variety of different graph types beforehand, or as you're going through, kind of reference back of a like, see, you remember when we saw that in that unit, or look, we co-constructed this histogram together of things. Like you can sort of point to, you don't even need to name it as a label, but you can sort of point towards that graph and be like, that's an example of a histogram. We were talking about the predicted high temperature today in our hometowns. Like that's an example of a histogram that we were creating together. And that sort of referencing visualizations folks have already seen can be really helpful. For some of our students, it can be really helpful to have an actual real life example next to that icon. And sort of that visual cue of this is what we're talking about as a graph type, and this is an example of that graph type. And by putting those two together, what we found is that helps keep it as a graph type and not just sort of be like, oh, okay, we're going to be looking at like the predicted high temperature and getting into the data specifics of it. So I share that out as a Maisie in case that helps as you were thinking. You guys are adults, so I threw you a little bit more into the deep end this evening as you were looking at it. But I did want to share that that's a common sort of adaptation adjustment that many teachers we hear use when they're using this with their students. Did that, Maisie, sort of spark any ideas or resonate with what you all were talking about in your breakout room?
Yeah. And then a follow-up question, which is not closely related, but related. So it's sort of tying back to the opening example you used with us with the cups of coffee. Is there a website or a book or a resource you would recommend that would have survey type questions for middle school, high school students, other than my brain could think up, just thinking like if I were to do classroom activities or a weekly classroom like survey graph or whatever, just a line of innocent and interesting topics besides coffee.
Yes. So a couple
Or
things.
cats versus dogs.
Yes. So a couple things. The book that I showed is great. It's a great example, but you don't have to buy a book. So here I am. I'm on page 24 right now of our resource document. And this in green this resource in green is what I was saying of like, you can get in and you can access all the Google Slides for the different grade levels, all the materials if you want. So that's what this resource is. This resource, the data in real life resource, the first one in the list, we have put together suggestions of where to go out and find different visualizations. So slightly different than what you're asking. This is like where to go find some real world examples of what you are looking for, and some kind of graph components, graph pieces. So we've tried to put some resources in here for you. The question, so that's sort of one part, one thing that it made me think of your question. And then it seems like the other question is sort of how do we come up with your grade level equivalent of how many preferred morning drinks have you had today? Okay, I would suggest two things. One, I would suggest asking any young humans you have in your life, because it was absolutely hysterical what my sons told me the other day at the dinner table when I was asking them. And two, this is a great use of ChatGPT to be like, what are some questions I can ask about my students and make them into our graph? And not that I'm always like, use AI, but I think those could be some two good options if you don't want to say, go find like observe, collect, draw, or something like that. Also, ask each other in the cohort, kind of post we could put a question in the resource document and folks could drop in ideas they have. I could pull some ideas from some of our other schools of what they're running with their students right now, if that would be helpful.
Can I just make a comment quick?
Please.
So I took our pre-test scores and our post-test scores from my ecology unit, and I just put them in a Google Sheets, and then I had it make a graph of it. And I removed all the kids' names, and then on my daily entry task, I put the scores up. And so they could see the difference between the pre and the post-test. And they got really, really excited to know that that was their actual data. And so that had a whole lot of buy-in from them, because I've been trying to, in my entry task, at least once a week, trying to put a graph in there and have them notice something and realize something about it. And when it was their own data, it was a whole nother spark for them. And so I would encourage you to use your actual data that you're getting from your students.
Yeah, what a great way to like leverage the data you already have, right? You have to collect it. You need your gradebook data. If you're worried the students will like think about who they are, right? Totally de-identify it. It could even be from like last unit, right? I mean, you could sort of separate it in time if you've got some students that would like get a little over anxious about seeing their score in relation to others. But yeah, you guys are awash in data in terms of your grade books and what's there, or different formative assessments that you're doing. You know, anything that has a score to it, or even a grouping on a rubric, can be great ways to do it. That's such a great call out, Carrie, of like, use the data you have. And it's the same exact principle of why that co-constructing visualizations works. They like talking about themselves. Sometimes that's really frustrating when you need to get them oriented in a direction of where you want to be like teaching and learning for the day. This is an opportunity to be like, I'm going to meet you where you're at, and we're going to do what we're trying to practice on, in sort of hitting that sweet spot of a component. Okay. So we talked through co-constructing graphs. We've talked about sort of graph choice as a skill, and thinking about how our graph types all relate to different questions that we're asking, how they're different graph types at different grade levels. So like, great, we don't have to do them all, but like what's sort of our grouping of graph types that do fall into our purview, or our area that we can pull from to have students use and be working with as they are doing their visualizations. And we're going to sort of talk through one other component, one other strategy. And this is where you need that piece of paper that I was asking you about. But oh, right, before we get there, if this structure of how it's organized, of the graph types by the 3 questions, is not resonating with you, don't worry. There are other resources out there, no hard feelings. Please just, the whole point is just to like help our students not always be reliant upon us telling them what graph type to make, or reliant upon like Google Sheets chart editor, that we're instilling in them, we're empowering them. So there are a variety of different other resources out there that organize it in slightly different ways. So if what we've talked through with this activity is not jiving with you, I encourage you to check out one of the others. Some of the graphing programs that are built for our learners, grades 3 through 12, to be exploring data, making sense of data, have this built in to the system. So Data Classroom is an example that a bunch of schools in Oregon are using. If you're not using it, don't worry, but I just want to call out, like, some of them are building it in terms of their own graph wizard, but in a, like, so Google Sheets chart editor, it looks at your data and it makes a guess based on if it is mostly numbers or if it is mostly character, and the sort of extra layer to that, the back end algorithm of like, how are your data organized? And it makes a guess. The Data Classroom Graph Wizard is trying to build in components to help students think about it. And Maisie, they actually include more specific examples of questions in their Graph Wizard of thinking about it. They have 5 groupings. We do 3 because it's hard to remember 5. So we just group it down to 3. So I've put across the top sort of how it overlaps with what we were just looking at. But sort of students are prompted through to ask different questions to then get to some different options. It's not a yes, no dichotomous key, but it's sort of leading them towards some more tailored options to them. So I did just sort of want to throw that out there of like, there are different platforms out there that are built around helping students work with data and explore data. And I went through that quickly, but we'll come back to that. So what I want to talk about, for some of us, it's quite cold. For most of us, right, we're in the like 46 to 50 degrees temperature. Is that right? Yeah. So we're all sort of like, we're like hovering around sort of 40 to 55. If you had cherry trees in your backyard, they are likely not blooming. I will share, as a human who just moved to California, it blows my mind that we can have oak leaves on the ground and cherry trees blooming at the same time. Because I'm from the East Coast, where usually cherry trees like blossom at one time of year. So my question for you all is like thinking about anything that you've heard about cherry trees or you've seen cherry trees yourself before we even like get into the data and do this piece, what is on the slide. Do we have any predictions about when cherry trees blossom that folks want to throw out there? Anybody ever thought about cherry trees and when they blossom?
Isn't it usually May?
Okay, we got a vote for May, April, May.
In Oregon, in the Valley.
Okay, I love it. We got a vote for March. We got an April, May. Jameson, what are you thinking?
Oh, I was going to say, I used to live out in Baltimore, and so the ones out in DC around the mall, that was always late March, early April.
Oh, okay. So we got late March, early April as another prediction that we have. Excellent. Okay. Any others? So we're going from March to May. That's kind of our range that I've heard being thrown out. Let's look at some data. Okay. So I'm going to make this big on our shared resource document so that you can actually see it there. And let me share the screen again of what I'm asking you to do. So what I'm asking you to do is we've made some predictions about when cherry trees might blossom. And now I'm going to show you some data. I'll put it up in the screen and it's in your shared resource document. And I want you to pause and be like, can you actually use these data to answer this question? Always important to do that. Do these data actually help me answer the question? Hopefully you will agree that you could use some component of these data to answer this question. And then I want you to think about, okay, well, if I were to use these data, if we were to move forward and do an activity where we were like exploring how cherry trees blossom, which of the variables in this data set would you use to get at this question of when do cherry trees blossom? And then what kind of graph would you make of the data? Now, it says here, this quick sketch, no data plotting. So what I mean, I'm trying to look for a piece of paper that I can write on. Aha, here it is. Okay, so what I mean by quick sketch is like, I want to make a pie chart and I'm gonna have, these are my 2 different categories. I'm not actually calculating out like, is this 23%, like looking at the numbers. I'm just doing a like, this is the variable that I would use, and I'm kind of quickly sketching a pie chart. So we don't need any tick marks. We don't need any like actual dots of data on, or lines or bars based on the data values I'm about to show you, but just do like kind of a quick sketch of what kind of thing would you graph, okay? Does that make sense? Hopefully. Here are your data. The question is, when do cherry trees blossom? It is on page 22 in the shared resource document, if that's easier for you to look at. We're gonna take about a minute to look at these data. Think about, can you use any of these data to answer that question? When do cherry trees blossom? And then if so, which variables or attributes of the data would you use, and what kind of graph would you put it in? And find your piece of, using your piece of paper, do like a quick sketch of those pieces. Okay, 15 more seconds. Okay. So what I would love to hear and have you all hold up and show, for those that would be willing to share out with the full group, if you thought you could use some of those data to answer the question of when do cherry trees blossom, which variables were you looking at? Which variables were you going to use? We had row, year, full flowering date, time period, and reference name were our 5 variables in the data set. And what kind of graph were you thinking about? Would somebody be willing to share their thoughts first? What they were thinking? Okay.
Did you want to see my graph or just hear my thoughts?
I do. We want to do both. Can you show your graph? Is that possible?
Yeah, there are numbers on it. I don't know if that's wrong.
That's okay.
That's
okay. We like numbers.
And they are beautifully ugly.
So. Oh, nice. Okay, now that we've seen it, can you tell us a little bit about it?
So what I zeroed in on was the flowering date, which I assumed meant how many days from January 1st. So like 98 would mean 98 days in. And most of them were flowering in the early hundreds. I don't think there was a date beyond day 110. So there were like 590s, and then most of them were in the hundreds. And there didn't really seem to be a difference between the pre-industrial or post-industrial columns. Like the post-industrial numbers all also showed up in the pre-industrial numbers, so I considered that irrelevant.
So on the bottom, sorry. So on the bottom you had 90s.
So on the bottom I just had, that was the range of days of when they flowered, and then I was just stacking to show how many were in that. I guess you could call it a history. You couldn't call it a histogram. You could call it a bar chart, or a plot. But yeah, I was just putting tick marks to show how many were in the 90s and how many were in the hundreds. And I didn't actually
Awesome.
count them all up. So I just did a
Just like a
exactly.
loose sort
Symbolic.
of, yeah, symbolic. Awesome. So that's like a line dot plot where we just had like the frequency of the different options. Awesome. Mickey, it seemed like you were also gonna show up. Did you do the, were you thinking the same way as Maisie, or were you thinking something different?
Well, at first I did like a scatter plot, but then I realized maybe the years don't matter since the question didn't seem to indicate the years mattered. So then I did, I
So
don't
you
know,
had year versus what on the scatter plot originally?
day of the year that it bloomed. So this is
Okay.
my original scatter plot. And then I went to this thingy, I don't know what you call it, where, wait, box and whisker, right?
Mhm.
So this would be the average day that it, like if you took all those numbers of date and averaged it, and then the highest date and the lowest date.
So you
But
were thinking you could use a box plot for full flowering date or date of the year, and
yeah,
that middle line, not the average, it's the median. It always trips me up. But the, just sort of give a sense of the kind of the range of that flowering date. I love it. So we've got scatter plots, line plots, box plots that folks are using. Any other visualization type that folks were thinking about sketching out? Oh, Laura was doing a histogram of the date range. Date range being the date of the year, Laura. Was that the variable that you were looking at? The flowering date? Yep. Okay. Awesome. So one thing I want to call out is what we just did is we did a strategy where our students are looking at a component of data and thinking of, like, this is a strategy you can use to have them look at data and think about what would we do? Because we just came up with 4 different ways to visualize the same data to get at this question. This helps move students out of, teacher, what is the right answer? What is the visualization type that you want me to use? And so opening it up and having them do some exploration can be really helpful. We, Mickey, as adults, often, and Maisie, you brought this up too, we were like, well, I was looking for the time period, like pre and post industrialization, or I was thinking about the year. We adults love to complicate things, and we love to like shove more variables in. And sometimes I specifically gave us a distribution type question where it's like, you only need one variable to really get at this. So one strategy is just sort of having students think about that visualization at one time. Another strategy that you could use with these data is, so we were looking at these data, we were looking at, I counted this up and now I forget, I think there may be like 21 or 23 rows of data in here. This is a subset of data from Data Classroom that actually has 799 rows of data in it. And so that, like, maybe there's a difference between pre and post industrialization. You could ask that differently. What I want to show you here is within one click, we've now plotted 779 bits of data. And you might be thinking, like, is this helpful? Is this relevant? What am I thinking from it? But what I want to showcase is that there are programs that are designed to get kids in and thinking about it. So we were looking, let's also show year, because Mickey, that was something that you had brought up where we were sort of, does it matter the year and the flowering date? So we can look at that, or we could go to our time period and maybe we don't actually want to see year anymore, but we want to look at the time period and we want to look, is there a difference pre-industrialization to post-industrialization? So we could step into those next steps. With our graphing programs that are designed to get students exploring data, the clicks in to the data can be much faster. I am not necessarily saying that you need to do Data Classroom, but I am saying how we can look at the data, how we can explore the data, how we can think about the data is really different when we are leveraging technology tools than if we're always doing things by hand. And it's a give and a take because it depends on what the learning outcome is that we are after. If we are after our students understanding the interquartile range and how to mathematically calculate those as they're building out that box and whiskers, absolutely. It is really important to have them make that box and whiskers by hand. If we are running a lab experiment and we have a control and a treatment, and we're trying to help them see, was there actually a difference between our control and our treatment, or our two different categories of things, they can just make the box plot as the way to then make sense of those data as it relates to our lab experiment. So it's influenced by what our learning objective is, but sort of thinking about that and what opportunities there are based on the kinds of ways that we visualize our data is another thing to think about. So this was an example in Data Classroom. There are many examples out there. One that I want to draw your attention to is CODAP. It is entirely free. It will always stay free. And these 4 examples here, Data Explorer, CODAP, Data Classroom, and Tuva, have all been purposely developed, sorry, not for kindergarten, for grades 3 and above, to get students into exploring, tinkering, playing, visualizing the data. Many, if not all of us, have Google Sheets. It is a fantastic spreadsheet program that we have round peg squared hole into making visualizations for us. Well, but it is a spreadsheet program. It can calculate things, it can organize data, but these components are set up to help explore data. There is no one that is perfect for every situation. So we've built out this sort of like benefits and limitations of these different graphing tools. If you have any questions about these, please reach out. I am happy to talk with you about, based on your situation and what you're looking for with your students, what are some options. As I was saying, I know of schools all throughout Oregon that are using all 3 of these, CODAP, Data Classroom, and Tuva. And I think I was just talking to someone the other day that's using Data Explorer. Data Explorer is very high school science heavy at the moment. That's how they've been, it's newer than the other 3 to the market. So if you have any questions, happy to stay on tonight, or you can drop me an email and talk to you about it. But I did just sort of want to bring up this other component of how we're having our students interface with data and making their visualizations also influences what they're taking away and what they have opportunities to kind of explore and work with the data. Why are we talking about technology? Well, it's a reality of life, and we should be having our students work with it from elementary on, but how much they work with it increases as they get older. And this is a workforce readiness skill. It is also because it greatly influences and impacts the kinds of questions that our students can be asking with the data. Jameson, you brought this up earlier of like, well, if we're looking at a big data set and we're going to bin it into these groups for our histograms, it's really hard to do things with more than about 20 rows of data when we're doing it by hand. But we want our students interfacing with larger data sets. And so that's why this technology piece is a component. Okay, we've covered a lot. Actually, let me jump ahead. So we've covered like co-constructing visualizations about themselves, getting them to graph about themselves. So they're kind of practicing it on the fly, exposing our students to the concept of graph choice, having our students potentially do like a quick graph before they actually get into the data, to think about, to normalize that. There's multiple ways that we can look at the same data set, and or change up how we're having our students work with data by thinking where are there opportunities to integrate some technology. So before I explain kind of our next steps before next week, because remember, this is a really quick turnaround for these 2 sessions, I do want to give us a time to kind of pause and be like, whoa, okay, we've been going for an hour and 50 minutes. Like, this was a lot that we have tackled and talked about. So you can pick all 3 of these questions, you can pick 1 or 2 of these questions, but these are in our shared resource document. And let me scroll over there so that we can all sort of orient to where we are looking. So we are here at the bottom of page 22. And so pick a question. We're going to take about 2-3 minutes to do some individual reflection. I cannot give you time during the day, but I can give you some time to like pause and think and reflect here while we're together. So jump in, grab a bullet point for what is resonating, or what questions do you have, or what could you take, like how can you take this forward into your lesson plan development or into something you're going to do in the next week. More on that in a moment. But let's each just take a couple minutes to do some individual reflection for our different locations. Okay. Awesome. Awesome. So we've done some reflection. One, great job. So exciting to see sort of what's coming up. We will be coming through and sort of addressing some of these questions or some clarity around different things, if that would be helpful as we go forward. As well as super fun to see, we're already jumping ahead to like, how do I take this forward? What can I do with my students? Which is so fun to see, because we are meeting up again next Tuesday. January is this like really tight turnaround month. And so what I'm asking you to do between now and next Tuesday, if it is possible, if you can like even just find like a 15-minute chunk at the beginning of a class or at the end of a class, is to, so it can be related, maybe the stars have aligned and you have a lesson already in your books in the next week that involves graphing. If so, fantastic. If not, try to find a 15-minute window to do a bell ringer or do now or an exit ticket type thing about it, and pick one of the strategies from our list. The strategies being here, these different things that we have talked about in different components. Included in sort of adjust the lesson plan up or adjust your lesson plan for the day to kind of create space for that, and collect some student responses. And so if it's you're having the students sort of make these visual hypotheses, take a couple pictures of their visual hypotheses and bring it forward, bring it into the sort of into this shared Google Slides. Remember, this is what we used, or for those of you that were here that did the first topic this fall, this is what we used the fall. For those of you that were not part of the fall session, the way that we access that is here on page, what's now page 25 of our shared resource document. So the instructions for what to do are here. You can click on this and it will take you to our examples of student work. In fact, it will take you directly to the instructions for January 28th. So we've got the instructions, I inputted the strategies. Pretty soon you will all have these grade level. This was Annette and I saying, we need to add these for you. So I will make sure those are in this evening. And so you'll have an opportunity to be like, which strategy did you integrate in? And then what were you targeting in terms of graph skills? For your students? What did you see or hear your students? What did you notice? And then the second slide is where you can put those examples of your students' work. And so even if it's a 10-minute bell ringer or an exit ticket, try to find a bit of time to try one of these strategies with your students, remembering that, yes, as Tracy said, our session next week is shorter. It's just 1 hour. And the intention of that strategy is to bring student work examples to be able to talk to each other. Because in no way, shape, or form do we think that you're going to have this all figured out for your students between now and next Tuesday. But what we can do is get a better sense of where are students actually at? What is their thinking? What are you noticing about your students in terms of this creating or iterating or thinking about graph pieces components? If that doesn't make sense, stick around. I'll stay on for anybody who has any questions. I'll also send this in an email out to everyone. Thank you for all that you do. Thank you for all of your questions and all of your participation. It is such a joy to work with you all each time. I look forward to seeing you all next Tuesday. Just an hour this time. Whew, not these 2 hours. These 2 hours are long. Thanks for sticking with it. And if you have any questions, stay on and answer them or drop me an email. Otherwise, have a wonderful evening. Enjoy your dinner. Stay warm. Talk to you guys next week. Thanks, everyone.